Hey everyone, today we are going to be looking at a Yamaha SPX90 Series 2 effects processor. This is a non-working unit. I'm going to be repairing it and kind of going through a teardown at the same time of it to see what makes it work. So the SPX90 and 90 Series 2 were very popular effects processors by Yamaha they came out in the late 80s. The 90 was the original unit, followed by the 92 or the 90 Series 2, which came after it, which was an improvement upon the original 90. So I'll talk a little bit about the differences between the 90 and the 92. I know the differences because I have one of each, and I also have the service manuals which talk about them. So the SPX90 service manual itself covers the 90 unit, and the 92 service manual is actually just an addendum to the 90. It's very brief and short, and it even states right in the front that the circuitry of the SPX92 is almost the same as the SPX90. So this manual contains only particular items that are different from the SPX90. So please use along with the SPX90 service manual, which I have here. These are all available online. I just happen to have the printed copies, so I'll be using them through this video. It's a little bit easier to show what's going on. And one thing I really like about the printed copies is that you get these unbelievably massive schematics with them. They're huge, they're bigger than my bench, that make it really easy to troubleshoot, versus trying to go through multiple pages of a PDF file, following from one page to another, tracing traces, stuff like that. So they've got the whole analog section on one side, along with the digital analog converters, and AAD converters as well, and then the digital section on the second side, which is really, really nice. So that is one thing I like about the printed service manuals. So a lot of people wonder why, or if it's even worth repairing these older effects units. A lot of people say they sound like garbage, and that's not really the case. These are still really high quality units. Granted, it depends on your application. Certain applications that you're used to a brand new fancy or newer fancy lexicon unit, or even like an old classic 480L or similar. Sure, this isn't going to stand up either sonically or in terms of the reverb algorithms that are used, but for a lot of applications this is still a very, very useful unit. That's one of the reasons why I'm going to be fixing this too. Secondly, you can get these very cheap. A classic lexicon high-end 480L is going to cost several thousand, where I paid about $25 for this, mostly because it's not working, but typically these go for between $75 and $150 depending on condition. So this will probably need about $30–40 of parts, and I'll have a working unit out of it, along with some other little TLC to clean it up and things like that. So these units are notorious for power supplies. The power supplies in these are the weak point. I mean, this unit is over 30 years old at this point, so the power supply, in particular the capacitors in the power supply, are what go bad. That is going to be the main focus of this repair video. These are studio units. They're typically on all the time. The heat in there, I mean, they run hot, and the heat kills those capacitors after time. And the shelf life of those capacitors, even just sitting around not even used after 30 years, is starting to be questionable, let alone it's in an actual piece of gear that's on running that temperature. So that is probably the number one thing that you're going to see with all these units. And it's not just this specific SPX90. The power supply in this unit is used among the entire family of Yamaha FX processors, including the Rev 5 and Rev 7, which were the little bit higher quality and more expensive studio versions of the SPX90, which came out about the same time. I'll be doing future videos on the Rev 5 and Rev 7 as well, as I have a couple of those each that I need to work on too. So this unit is in pretty good shape. Overall it's good. All the buttons are there, display's there, it's all nice, there's not a lot of scratches. There's a dent in the ear, which isn't a big deal. That actually happened in shipping, but I'll put that in my vise and bend that out. I'm missing the volume control for the input pot. I don't know if I have one that's small. I'll have to see and dig around and see if I can find something for that. Besides that, on the back you just have your typical mono input, stereo output. That was typical for reverb units of the day. Even the older lexicons that were out around the same time as this had the same configuration. And then you've got your MIDI functionality as well, which became popular around that time too. So as I said, this unit doesn't power on. That was what the seller said. I am not going to power it on myself. I guarantee you it won't power it on. The capacitors in this, the power supply in this is going to be the problematic area. So we're just going to open it up and take a look inside before we do anything further. There are a handful of screws around the side and the back and the top, and the cover comes right off. So we'll go through, talk a little bit about the architecture of the way that it works in terms of the DSP and the analog digital analog conversions. It's actually pretty interesting on this older gear. And then we'll also look at the power supply. We'll look at the power supply first, because obviously I can see right now there's visible signs of what's wrong. So let's do that. So here's a closer look at the power supply inside the SPX90 Series 2. Again, the SPX90, the Yamaha Rev 7, the Yamaha Rev 5, among other Yamaha units from this era, are pretty much all going to have the same power supply. There's slight revisions between the models as this power supply evolved, but it pretty much remains the same. It's just a very basic switch mode power supply that provides a plus and minus output for the converter units, usually either plus or minus 15 or plus or minus 18 volts. And then there'll be a separate 5-volt output to run all the digital logic. This is from the area where everything was just straight TTL, and various other, some CMOS in there possibly too. It's all going to be 5-volt. So all you needed was a 5-volt output to run everything there. Usually pretty high current too. The amount of electronics in this is pretty significant and would probably draw a couple amps. So obvious signs of what's wrong in the power supply are pretty easy to spot, and like I mentioned, capacitors are there. This one is bulging pretty bad, the main cap on the switch mode power supply there. And then you can see all the filtering caps on the output are actually leaking as well. So, I mean, they are pretty much toast at this point. And I had a feeling of that, which is why I didn't want to power this up when I received it. So the electrolyte is actually leaked out of there, and it's corroded some of the components as well. The lead on that little ferrite bead there, or diode, is actually pretty corroded. Along with the board down the bottom here. There's some corroded leads in some of those components. So we'll have to be careful as we're cleaning this up to make sure that none of those have, the acid hasn't ate through those leads there. Secondly, there's this typical little bit of, it's almost like epoxy they put on the components to keep things from bouncing around. And typically over time this stuff gets hard, and a lot of times it'll become conductive. And you can see it's actually just chipping up the board right now with some light pressure. So I'm going to go through and scrape all that off as well and remove all of it out of here, because that could be cause potential problems as well. So for this power supply, I will go through, replace all the capacitors, clean the board in the process, look for any other signs of problems in here. There very well may be other problems besides the caps, that have happened over time. So we'll disconnect it from the actual, board itself and test the outputs after we replace capacitors in here to see what voltage we get. Looking at the rest of the power supply, like I mentioned, it's pretty simple switch mode. AC in, you got your power switch that is linked to the front. Fuse, you've got your input filtering, a couple of knobs and capacitors, common mode chokes, and then you've got the switch, mode power supply here, or you've got your high frequency transformer along with your driver. Steps up the voltage to a very high frequency, then drops it back down. And then on the output side, you've got all your filtering here through these various inductors and capacitors. And then there's a small variable resistor here, probably to adjust the 5-volt output voltage. So here's a little bit closer look at the power supply now that I have it out. It's actually held in, it's soldered into the main leads here, which I'm just going to leave connected because I can still work on the power supply just fine. But this region here, you can see the capacitors that were leaking that I was talking about. Almost every single one is, and along with that you can see the corrosion in this connector here. This diode here is pretty well eaten up, along with this resistor and diode over here. So all that will need to be cleaned up and inspected as we're putting this back together. This big cap on the main switching portion of the power supply, you can see how it's bulged. Typically these big caps don't go bad, so this just shows you how hot this thing gets. So these caps themselves, let's see, they are only 85C rated, and they are Nishikans. So they're not cheap caps, they were good caps, but again, only 85C rated. So partly one of the reasons why they fail in these units over time. They're not rated for the higher temperatures that you typically would see with a power supply like this. I don't know exactly how hot this runs, but just based on some of the coloring on the board, you can tell that it does get pretty warm. Plus it's 30 years old, and it may never been shut off. It could be on for 30 years for all we know. So we will start with replacing these caps, cleaning the board, and then once we have that all taken care of, we will power this up and then check voltages on the output and see if we actually have voltages coming out of here. Now I'll also mention that the capacitors need to replace aren't limited to the power supply in this board. If that is the culprit and I get this working and the power supply is good, I will go ahead and begin replacing the capacitors on the analog portion of this board as well. So there's a lot of electrolytics here in the analog pathways and some basic filtering stuff for some onboard regulators, etc. But even over here, if you look, there's a couple caps here that are also bulging on the backside, which are definitely bad. So those will need to be replaced as well. Now in terms of the capacitors that I'm going to be using to replace this unit, I'm going to be using Panasonic 105C rated electrolytics. I'll be using these throughout the entire power supply and any regulator related capacitors. These are very, very good and very high quality capacitors I've used for a long time in tons of gear, and they've always been very, very reliable. Now you can use whatever favorite capacitors you have, it doesn't really matter. All the high-end brands are going to be fine, be it Nippon Chemicon, Rubicon, etc. So whatever you prefer is good. Just make sure they're 105C rated. That's really the key for this equipment that runs hot. For the analog audio paths, I'm going to be using ELNA caps. In this case, the RFS series. So these are really, really high quality capacitors as well, designed for audio applications. Now, I'm not big into the whole, audiophile world of swapping out components and things like that for, massive differences and things. But what I am into is using really high quality components that are rated very well specification-wise for the application at hand. And that's why I'm going to be using the ELNAs for this. The downside is the ELNA RFS series is only 85C rated, not 105. But because they're in the analog portion of the, on the digital board, separate a little bit from the really hot components of the power supply, it'll be fine in that regard. All these little caps here are 85C rated, and they've survived for the most part 30 years. So we'll be alright using these caps in that regard. These are two of the worst right here. These are 330 at 25 volts, and those go on basically the plus and minus 15 rail for the analog portion of this unit. So they are pretty bad. Alright, all the caps are replaced. I scraped all the nasty glue out of there. I cleaned the board as much as I could, just cotton swab. I checked all those leads that were corroded. They're all intact. None of them are actually broken at this point. I still need to clean a little bit in this connector, get a little more corrosion out of there, but I think we're okay at this point. So it should be safe to power this up. I'm going to ramp it up slowly on my Variac and monitor the voltage both from the 5 volt rail and the plus and minus 18 on here, and just see if it gets up to where it should be. Alright, so to test this, I'm going to ramp up the voltage slowly for my Variac while watching the output of the 5 volt rail. I'll monitor 5 volt first, and then I'll switch over to the plus or minus 15 volt, or in this case 18 volt. It's actually coming off the supply to make sure that it's within spec as well. So power on, and start ramping up the voltage. About 80 volts AC. It's not drawing any current. Voltage is climbing, about 100 volts AC. Still not drawing any current, which is good. 100 115 volts right there. 4.7 volts DC. So I bet you I could probably tweak that pot there and get that a little bit closer. I'm okay with that right now though. So I haven't looked at the specs yet to see what the acceptable voltage range for this unit is. So I'll leave it alone for now. But that looks good. So based on that, let's monitor the 18 volt rails right now as well. So negative 16.7. 21. So a little bit of variance there between those two. Not entirely happy with that. It's quite a big difference. It's okay because you've actually got 15 volt plus and minus regulators on the board here. So as long as the voltages coming off of here are high enough to reach the minimum specifications for those two regulators to get the plus and minus 15 volts to your DACs, we should be fine. So we'll check the voltages off of there once we have the main board hooked up to the power supply here and make sure those are within spec before I start messing around with anything else here. But power supply should be good. I haven't checked for ripple. It's probably fine. If there's noise or any issues in the unit, I'll look at that point. But with the caps replaced in there, it should be filtering properly as far as any high frequency noise coming off the switching supply. Just out of curiosity, let's take a look at the new to the old cap that was replaced. So these 330 microfarad 25 volts, let's see what they're actually reading. So 210 microfarad instead of 330, so definitely low. Compare that to a brand new cap. Well, this is one of the Panasonic 105C rated caps, low ESR. And it will read 326, so 330 within the spec of this. So you can see the definite difference in these. Again, this meter won't measure ESR, but I guarantee you it's probably a huge amount of resistance in these as well. Alright, I've got the supply hooked back up to the main board here, and we will power it on. And we got nothing. Quick little flash here on the lower portion. So there's definitely something still up. So let's start checking more voltages. We will check that 5 volt rail first. Something is sinking it way down. I'm only getting half of a volt on there, which is not right. Just to make sure, let's pull that back off. Measure this again. .5 volts, 4.6. So that's up there, like it should be. You'll notice that I heard some relays click here too with that removed, just getting the 18 volts. There. So there must be a delay circuit for the, that's most likely the audio switching inputs, power on, turn on delay. Or it could be part of the bypass, I'm not sure, I'll have to look at the schematic. But the 18 volt side for the regulator seems to be okay. Just a quick little mention over here too. So when your backup battery goes bad, just buy the right cell. Don't do this. This is sad. It's like, come on. That's not what you want to do. We are not going to deal with that. Before I do anything further, I want to adjust the 5 volt rail pot for the digital 5 volt output on this power supply. I measured it again, it's even lower. It was like 4.5, now it's floating around 4.6, 4.7. And you know, this TTL logic stuff is very touchy to the voltages that are there. So let's adjust it, get it up to at least 5, and try powering it on again and see where we're at. So, I mean, this pod is kind of crusty too. It's just your old school metal swipe on a carbon, metal wipe on a carbon board basically, so it's pretty touchy and it's probably dirty. But anyway, just for testing this, get it right around 5.02, close enough for me. So we'll hook these cables back up and power it on. Alright, let's take a look now. And look at that, we got power. Display's a little dim, low battery warning, that's fine because I cut it out. But it's working. I mean, the digital portion's working. We got to run audio through it to see if there's actually reverb or any effect for that matter. But that is promising. So we still have some more things to do. Like I mentioned, a lot of these caps on the digital or the analog portion of the digital board are definitely leaking and bulging and old. I want to replace those. At this point, I think I just want to run some audio through it and just make sure that we have reverb that will confirm that everything on the digital side is working properly, which will be good. And then we can tackle the caps on this analog section within here. So, alright, so as a test right now to see if the reverb is working, I've got the SPX90 Series 2 on my bench being fed by my Roland XP50, which is sitting next to it. And then I've got the audio output of the SPX feeding just to my computer sound card, and then through the little desktop speakers I have on my computer. So the audio is not good by any means out of those speakers, but it's a good enough test just to see if it's working, which it is working, which is cool. So just to verify, I can bypass, reverb off, reverb on. So the DSP is working. The entire digital section looks to be working just fine. All the conversion looks to be working. So the next step will be to go through and replace the remainder of those caps on the analog pathways. Again, there's only a couple that look bad that I probably need to replace, but at this point I'm just going to replace them all because they are old, and why not? You know, it's only another $10 worth of caps, so it's not that big of a deal. It's just a little bit more time to do so. Alright, for one last voltage check, I just want to look at the plus and minus 15 supplies and make sure that we actually have the within spec voltages on there anyway. So 18 in, 15 out, and then on the negative supply, negative 18.5 in, negative 14.77 out. So, very close. It's good. It's within spec, so I'm happy with that. I think from the power supply standpoint, we are good. So we will go for the digital board at this point. So this will end part one of the Yamaha SPX90 Series 2 teardown and repair. At this point, we have it working. It still needs a little TLC. So in part two, we'll look at the remaining section of the digital board, including replacing the caps we still have left here for the analog pathways and a couple of the power supply circuits on this board too. And then we'll really go into the teardown. We'll look at the schematic, we'll look at the parts on the board, we'll discuss how this thing actually works. It's pretty interesting the way that they did DSP in the early or late 80s, I should say, particularly in the analog to digital conversion. So I hope you enjoyed this so far, and thanks for watching.